What if I told you the most powerful data analyst on your team doesn't actually know how to do math?
I mean, that sounds like a massive hiring failure, honestly.
Right. It sounds terrible. But today we're looking at how language models, tools that are, built entirely for words, just predicting the next token in a text sequence, are completely rewriting the rules of quantitative data analysis.
Yeah, we were moving way past the novelty of just having AI summarize a long email. We're looking at taking a raw 12-month operational spreadsheet and like actually turning it into a strategic action plan.
Exactly. So, welcome to the deep dive. We're speaking directly to you today, the professional who is just constantly juggling reports, budgets, dashboards, and, those complex narratives.
And you probably know the basics of AI by now, but today's source material, which is a chapter titled Working with Data in AI Chat, it really pushes us into a completely hands-on, highly practical workflow.
Yeah, the mission for this deep dive is to really break down the mechanics of using AI features, things like chat, projects, and NotebookLM. But for hard numbers, we're going to explore how to properly format data so the AI actually understands it, how to force it to run accurate calculations without hallucinating, and what to do when your source material is just a complete mess of text and tables.
And the distinction between qualitative and quantitative tools is really the critical starting point here. I mean, professionals have largely embraced tools like NotebookLM as their go-to for, narrative-heavy content.
Right, like policy documents.
Exactly. You feed it a strategic plan or an annual policy document, and it synthesizes the text beautifully.
Hmm.
But when you are staring at a massive dashboard export or a budget variance report, a purely qualitative tool just isn't the right instrument.
Because it's structured data, you need a tool designed to read a grid, perform specific calculations, and iteratively draft interpretations. And for that, the source indicates you need AI chat environments, like Claude, ChatGPT, or Gemini.
Yeah, but we really need to look at the underlying mechanics of how these models actually, see that structured data. I mean, we all know how to copy and paste a table or drag and drop a CSV file.
Sure, that's the easy part.
Right, but the real issue is what happens inside the model the second you hit enter. When you drop an Excel file into a chat window, the AI does not see a visual grid. It doesn't perceive rows and columns the way our human eyes, scan a spreadsheet.
Wait, so what does it see?
It flattens that entire table into a long, continuous string of text tokens. So the spatial relationship, the fact that cell C4 is directly underneath cell C3, is entirely dependent on how the model parses those tokens.
Okay, let's unpack this, because that means if your formatting is sloppy, the data is instantly corrupted in the AI's mind, right?
Oh, absolutely, instantly.
So the source actually emphasizes a golden rule here. You must include explicit, unambiguous column headers, because dropping unlabeled data into an AI it's like handing a stranger a ring of unmarked keys and just asking them to find your front door.
That is a great analogy. It sees the numerical shapes and patterns, but it has absolutely no idea if it's looking at patient volume, annual rainfall, or monthly overtime hours. It's a structural necessity.
Because it needs that context.
Exactly. When you label a column, say ICU OT hours, you are giving the model a semantic anchor. As it reads that flattened string of tokens, it uses that header to map the relationships between the numbers.
And
Without it, the model just tries to infer the context based on general data patterns, which is a massive gamble when you're dealing with, proprietary operational data. Just taking 30 seconds to clean your headers and remove those merged cells before you upload, it changes the entire trajectory of the analysis.
So assuming our data is cleanly labeled and uploaded, we shift from data entry to data extraction. And dropping a pristine spreadsheet into the chat just to ask, hey, what does this data show? That feels like a massive waste of potential.
It totally is. It yields a uselessly broad summary. The tool will essentially just regurgitate the dimensions of the data set back to you. Like, you have given me 12 columns and 50 rows.
Which helps nobody.
Right. The professional shift here is moving away from asking for summaries and instead prompting for specific variables. The source actually breaks this down into 5 distinct analytical question types.
Okay, let's trace a specific data set through those 5 types just to make it concrete. Imagine you are a healthcare administrator and you just uploaded 12 months of overtime data across 6 different hospital departments.
I'm with you.
The first prompt type is trend identification. So instead of asking for a summary, you'd ask, how has patient volume and overtime changed month over month? And are there any specific departments driving the overall pattern?
Yeah, that's perfect. Because you were forcing the model to evaluate directionality, and consistency over a time series. And once you establish the trend, you move to the second type, which is comparison.
So comparing two different things.
Right. You might prompt, compare the overtime volatility between the ICU and the medical surgical unit. Now the AI has to isolate those two specific variables, run a comparative analysis, and evaluate which data series is, less stable.
Which leads right into the third type, anomaly detection. So you ask the tool to flag outliers, like, are there any data points in the ICU series that fall significantly outside the established pattern, and what might explain them? But wait, let me push back on this one for a second.
Sure. What's the hangup?
If the AI flags an outlier, how do we know its explanation isn't just a wild guess? Like, it doesn't actually work at my hospital.
Well, what's fascinating here is that you're totally right. That second half of the prompt, asking what might explain them, is where you really have to understand the limits of the AI's context.
Because it is just guessing, right?
The model will absolutely flag the statistical anomaly. It will spot that, hey, March had a 400% spike in overtime. But its explanation is purely a generalized hypothesis. It might suggest, like, seasonal flu spikes or staffing shortages, because that's what typically happens in hospitals.
Right, it spots the dot, but it doesn't actually know what happened in my specific hospital last March. Like, did we implement a new electronic health record system that slowed everyone down? Did a competing clinic close across town?
Exactly. Which means the true analytical burden shifts from identification to contextualization. The AI handles the tedious labor of finding the needle in the haystack, but you have to apply your own organizational knowledge to determine if that needle actually matters.
That makes a lot of sense. So after we evaluate the anomalies, we hit the fourth type, which is calculation.
Yeah, this is where you prompt the AI to, say, find the average monthly patient satisfaction score and calculate the variance for each department.
Which saves the 20 minutes you would have spent fumbling around setting up pivot tables.
At least 20 minutes.
Yes.
And then finally, the fifth type is narrative translation.
Translating the raw mathematical outputs into actual stakeholder communication.
Right. You instruct the AI to summarize the staffing trends, the comparative volatility, and that March anomaly we talked about into 3 paragraphs tailored for a non-technical vice president who, just needs the bottom line, but absolutely refuses to look at raw spreadsheets.
So you chain those 5 prompts together: trend, comparison, anomaly, calculation, narrative, and you essentially have a comprehensive analysis. But here's a question. If I close the browser tab to go to a meeting, does the AI just develop amnesia?
Unfortunately, yes. The context window resets entirely. Every standard chat is just a blank slate.
Oh, wow. So if you return the next morning to ask a follow-up question about that same overtime data, you have to re-upload the spreadsheet.
So we have to re-upload it, re-explain the headers, and try to recreate all those analytical parameters from scratch.
Right.
It is an incredibly high-friction way to work.
To fix that, you really have to anchor the data. And the source text points to the project's feature in tools like Claude and ChatGPT as the solution for this. It transforms a one-off chat into a persistent workspace.
Yeah, a project workspace fundamentally changes how the model treats your data. You upload the core dataset once, and it acts as a foundational reference document. It basically lives outside the transient day-to-day chat window.
And more importantly, projects allow you to set overarching system instructions, right? Instructions that dictate how the AI should behave across every single conversation within that workspace.
Exactly. Those system instructions are separate from the specific user prompts we just talked about. You are basically programming the AI's persona.
The source actually suggests a specific instruction example, something like, I have a healthcare administrator at a mid-sized community hospital analyzing 12 months of operational data. Present findings in plain language suitable for a non-technical audience. When you identify trends, suggest hypotheses, but explicitly flag them as requiring human verification.
I love that example. By setting those parameters at the system level, you eliminate the need to provide context over and over again. Every time you open a new thread within that project, the AI already knows your role, the audience, the tone, and the structure of the data.
So you can have one conversation thread isolating budget constraints, a completely different thread analyzing nurse retention, and a third thread generating executive summaries.
All drawing from the exact same underlying uncorrupted data set.
It kind of mirrors how you interact with an actual human team member. Like, you do the heavy lifting of context setting once during their onboarding, and from then on, you just drop by their desk with a quick question, knowing they already possess the organizational background to answer it accurately.
It's a great way to look at it. It allows for iterative, sustained analysis over days or weeks, which is, frankly, how real professional work actually happens.
But we need to address a glaring technical contradiction here. We opened this deep dive by noting that language models are essentially text predictors. They don't fundamentally know math.
Right, they don't.
So how is this text predictor suddenly calculating complex month-over-month variance or building pivot tables without hallucinating all the numbers?
Well, this is where we look at the mechanism of what we call light coding, or advanced data analysis features. When you ask a modern AI chat tool to calculate a complex variance, it does not try to guess the answer by generating the most likely next word.
Okay, so what is it doing?
Instead, it writes a short script, usually in a programming language like Python. It actually spins up a hidden, secure computing environment, executes that Python code against your uploaded spreadsheet, and then reads the actual mathematical output.
Here's where it gets really interesting, because that is a massive paradigm shift. The AI is fundamentally changing its own behavior. It realizes it cannot guess the math, so it builds a calculator on the fly, uses it, and hands you the result.
Exactly. Which means you are directing the tool to execute technical functions without needing to know a single line of Python yourself. You can upload a messy dataset and just prompt the AI to remove duplicate rows, standardize inconsistent date formats, and calculate percentage changes across multiple columns.
You are no longer the person sweating over the exact syntax of an Excel formula. You are the director, and the AI is the technical crew.
Right. And if you prefer to keep your data local and do the work inside your own Excel sheet, you don't even have to use the AI's hidden environment.
You just ask it for the formula.
Exactly. You just tell the AI, write an Excel formula that calculates the month-over-month percentage change starting in cell C3, referencing column B, and handle any zero division errors. It spits out the exact string of text. You copy it, paste it into Excel, and you are done.
But stepping into that director role introduces a whole new layer of professional responsibility, because the skill is no longer writing the script. The skill is describing the desired outcome with absolute clarity and then acting as the ultimate quality control layer.
Yes, you are the risk layer now. Because if the AI is writing hidden Python scripts to manipulate thousands of rows of data, what happens when it gets it wrong?
Yeah, AI mistakes with quantitative data are terrifyingly subtle. If an AI hallucinates a fake book title in a historical summary, it really stands out. But a 3% calculation error buried in a massive operational report.
It slips right past you. And the consequences are entirely real. A bad calculation can lead to a hiring freeze, misallocated budgets, or, unnecessary cost cutting.
So what are the traps we need to look out for?
Well, the source text warns of several specific ones. LLMs frequently struggle with ambiguous schemas. So if you have a row at the top of your data that acts as a subheader, the AI's Python script might count it as a data row, completely skewing every subsequent average.
Oh, that's dangerous. It also falls hard for the correlation trap, doesn't it?
Big time.
Yeah.
It looks at two columns, sees that ICU overtime went up in the exact same month that, paperclip purchases spiked, and subtly implies a connection in its narrative summary.
It completely lacks common sense. That is why the mandatory safeguard the source talks about is aggressive spot checking. But practically speaking, how does that work? If I use AI to process 10,000 rows of data, I cannot manually verify every single cell. That just defeats the entire purpose of automation.
Well, if we connect this to the bigger picture, you don't verify every cell. You manage the risk by verifying the load-bearing statistics.
What do you mean by load-bearing?
If the AI generates an executive summary claiming that overall department overtime increased by 23% between Q1 and Q2, that is a high-impact claim. You must manually open your original spreadsheet, run that specific Q1 to Q2 calculation yourself, and confirm that exact 23% figure before you ever put it on a slide deck.
Ah, I see. I check the foundation. If the core percentage holds up to human scrutiny, I can trust the broader summary it built around that number. You use the AI to generate the insight at high speed, but you retain full accountability for its accuracy.
It's the only way to protect your professional credibility when using these tools. You have to trust, but verify.
So we have a robust workflow for structured, quantitative data. We know how to use headers to help the AI map the tokens. We know how to chain prompts to isolate variables. We use projects to maintain context. And we know how to spot check the Python outputs.
Right.
But earlier, we established that Notebook LM is superior for qualitative narrative documents. In reality, though, source material is rarely that cleanly divided.
No, it's the most common hurdle professionals face. A standard quality improvement report might open with 4 pages of dense historical context, regulatory updates, and strategic goals,
Hmm.
immediately followed by 2 pages of complex data tables tracking the actual outcome metrics.
The dreaded hybrid document. If I upload that whole thing to Notebook LM, it handles the history beautifully, but fumbles the math.
Yeah, it will struggle with the tables.
And if I put it in ChatGPT, it crushes the math but kind of loses the nuance of the regulatory narrative. So what does this all mean?
The solution is to unbundle the document and combine your tools. The idea of a single, omnipotent AI app is a complete myth. The highest performing professionals build a customized workflow.
So how do we split it up?
You upload the entire hybrid document to Notebook LM. You use its robust grounding capabilities to interrogate the narrative sections, generating a synthesis of the history and the goals.
Got it. Then I extract just the data tables from that original document, clean up the headers like we talked about, and drop them into a persistent project workspace in Claude or ChatGPT. And from there, I run the 5 analytical prompts to find the trends and anomalies.
Exactly. You let Notebook LM handle the story, you let the chat tool handle the math, and then you, the human, synthesize those two parallel outputs into a final, cohesive stakeholder presentation.
Moving data between specialized models isn't a workaround then.
Not at all. It is the definitive professional workflow.
It fundamentally changes how we interact with information. We are no longer bottlenecked by our ability to write formulas or manually scan thousands of rows for an outlier. The technical execution is basically becoming a commodity.
Which brings us to a rather provocative shift in our daily work. I mean, think about it. For decades, the value of an analyst or a manager was heavily tied to their ability to compute the answers.
Right, they were the ones who knew how to build the complex pivot tables, how to clean the messy CSV files, how to find the variance. The person who could navigate the spreadsheet fastest had the most value.
Exactly. But if the AI is now spinning up its own hidden environments to write the code, execute the math, and instantly spot the anomalies, the premium on computation drops to zero.
Wow.
The true value of a professional shifts entirely. You are no longer the person computing the answers. Your sole critical value lies in your ability to ask the right questions.
You have to know why you are looking at the data in the first place. You have to know the business context well enough to realize that a 400% spike in March isn't just a statistical anomaly. It was the month the new software launched.
Yes, the AI provides the velocity, but the human provides the vector.
The human provides the meaning. That is a phenomenal thought to leave on. Thank you for joining us on this deep dive. Don't wait for your next massive report to try this out. Grab a small spreadsheet today, make sure those headers are crystal clear, drop it into an AI chat, and start experimenting with those specific analytical prompts. Until next time, keep diving deep.